Section 7.1 Equations of circle. Last lesson, we learned how to find the equations of circle on the coordinate plane in standard form, or called the center radius form. For this one, we have to know two important things. One, we have to know the center, the coordinates of center. And second, we have to know the radius r. And now we will learn how to express the equations of circle in general form. Let's take this equation in standard form as an example. Here, for these equations in standard form, we try to expand by using identities. And we try to transposing the terms and make one side equals to 0. And we will call this the general form of the equations, which is x squared plus y squared plus dx plus ey plus f equals 0. And here, d, f are constant. There are some points to note for these equations in standard form. First, we found that the coefficients of x squared and y squared are the same, and in this case, both equal to 1. And here, for these equations, we don't have term in xy. We also call this cross term. There is no cross term in the equations of circle. Third, for these equations, the highest degree of the term is 2. So we call this the equation is quadratic. And the highest degree of all its term is 2. Now let's try two simple examples. The first one, you have to find the equations of circle with center -1, 2, and the radius is 5. And you have to find in general form. So here, by using what we have learned in the last sections, we can first express the equations in standard form. Then we try to expand by using identities. And we move all the terms to one side and rearrange the terms as x squared plus y squared plus 2x minus 4y minus 20 equals 0. This is the equations in general form. Now, example 2. Still, we have found the equation of circle in general form, and we are given the center and the radius. Can you try yourself? Similarly, the equations of circle we first express in standard form, and then we try to simplify and we write into general form. This is the equations of circle in general form, with one side equals 0. Actually, we can rewrite any equations of circle in standard form into general form. Here, by expanding and transposing the terms. And rearranging the terms. We got this. This is the equations in general form. Here, we try to compare the equations that we have already got. And we learned previously. Here, we compare the coefficients of like terms. We get the following relations. Here, d equals negative 2h. And we have e equals negative 2k. And finally, f equals h squared plus k squared minus r squared. Now, we try to make h, k, and r be the subject of the equations respectively. So we have h equals d over negative 2. K equals e over negative 2. And r equals h squared plus k squared minus f square root. As r is positive, we only take the positive square root. And for h, this is actually d equals d over negative 2. And k is e over negative 2. So we got this. So from the equations in general form, we can have the formula of finding the center and radius in terms of DEF. The formulas are as follows. For the center, we have d over negative 2, e over negative 2, and the radius we can use DEF to find the radius of the circle. And also, actually, if we have already found the center, HK, here we can also use h squared plus k squared minus f to find the radius. So here we got two important formulae to find the center and radius of circle from the general form of the equations. There are some points to note here. Before we apply the above formula to find the center and the radius of the circle from the general form, what you should make sure is that the coefficients of x squared and y squared are both equal to 1 in order to use the formulas correctly to find the center and the radius. Second, we have to pay attention to the terms under the radical size of the radius. If the term under the radical size is positive, greater than 0, that means r is positive. So for this case, the equations represent a real circle. And if the term under the radical size is equal to 0, we have the radius equals square root 0 equals 0. And for this case, the equations of circle represent a point circle. And for the third case, when the terms under the radical sign is negative, then we have r equals square root a negative number, so which is an imaginary number. And for this case, the equations of circle represent an we call imaginary circle. That means actually, although we have the equations of circle in the general form, we cannot draw the circle on the coordinate plane.